Hello friends, we are going to learn big M method today. In the previous video, I have taught you simplex method. The difference between simplex method and big M method is that in big M method, we will be having equals to and greater than equal to sign, whereas in simplex method, we only have less than equal to sign in the subject to the constraints. So here is the question on big M method. We are having a maximizing optimized problem and the subject to constraints are having equal to, less than equal to, greater than equal to and less than equal to sign. So we will be writing a statement. Since the given optimization problem is of maximized type problem and the constraints are of greater to, hence we will be using big M method. Now we have to again rewrite these subject to the constraint by balancing their both LHS and RHS. So as we can see that the first equation is already balanced, so we need to add a artificial variable, as we can't add or subtract surplus variable or slack variable. So our first equation will be x1 plus x2 plus x3 plus a1. a1 is our artificial variable equals to 10. Now we can see that the second equation is of greater than equal to type, so we can't add slack variable to its LHS side, so we need to subtract a surplus variable from its LHS side and add an artificial variable so that it becomes equal to 1. x1 minus x2, we will be subtracting surplus variable. S1 is our surplus variable and we will be adding artificial variable. These artificial variables cannot be same, so this one will be represented by a1 and this will be represented by a2, which is equal to a1. Now the third equation is of less than equal to type, means our LHS is less than RHS side, so we will be adding a slack variable in it. So the equation will be 2x1 plus 3x2 plus x3 plus s2. s2 is our slack variable, then the equation is equal to 30. Now we will be writing a maximizing equation once again also. So maximization z equals to 4x1 plus 5x2 minus 3x square. These are the same value of above. Now we will be writing these also. So s1 is our surplus variable and we don't need any effect to be made on our optimization problem, so we will be multiplying this by 0. Same goes with s2. s2 is our slack variable, so we will be multiplying it by 0 and we will be subtracting a1 a2 and we will be multiplying these by m. M here is the biggest value we can assume. Now coming on to the table, we will be making the tables as we have made in the simplex method, but there will be few changes in it, a bit of change. So how to fill the values in table 1? The tables are constructed same as we have done in simplex method. we have written the values which we are having in the variables which we are having in the maximizing equation. So the value of x1 is 4, x2 5, x3 is -3, s1 is 0, s2 is 0, a1 is -m, a2 is -m. So values are 4, 5, -3, 0, 0, -m, -m. Now BV basic variable are A1, A2 and S2. So the values of CB will be -m, -m and S2 is 0. Now how to fill the value over here? In equation 1 we are having XB's solution as 10, 1 and 30. So 10, 1 and 30. Now values over here, it will be x, we are having 1, x2 also 1, x3 also 1, value of a1 is also 1, 1, 1, 1, 0, 0, 1, 0. Now value of x, equation 2 is x1 is 1, x2 is -1, s1 is -1, a2 is 1. So the values will be 1, -1, 0, -1, 0, 0 and 1. Now in equation 3 we are having x1 as 2, x2 as 3, x3 as 1, s2 as 1 and rest others are 0. So 2, 3, 1, 0, 1, 0, 0. Now we are going to calculate Zj. How to calculate Zj? -m multiplied by this plus -m multiplied by multiplying these and adding these all. So -m into 1 is -m, -m into 1 is -m, 0 into 2 is 0. So -m gives us -2m. Same we will be doing for rest of these. So it will be 0, -m, m, 0, m and -m. Now in simplex method we used to calculate Zj minus Cj, but in big M we will be calculating Cj minus Zj. So Cj minus Zj will be 4 plus 2m and this would be 5 minus m plus 3 minus m 0, 0, 0. Now the biggest value over here, we will be calculating the biggest value now. In simplex method we used to calculate the minimum value, but here we will be seeing the biggest. So this would be our key column. This is our biggest value cause m is the biggest number we have assumed. Now how to calculate the minimum ratio? It's xb upon key of divided by key column. So it will be 10, 1, 15 and the minimum value over here is this. So this will be a key row. Now where the key column and key row are intersecting is at over here. So one is our key element. Now with the help of table 1 we are going to construct table 2. So values in table 2 will be, Cj's value will be same in each and every table, 4 5 minus 3 0 0 minus m, and the leaving variable is a2 and entering variable is x1. So a1, x1 and s2. Now the values of cb, a1 is minus m, x1 is 4, s2 is 0. Now how to fill these values? First, for the new variable which have entered is x1, so value of this will be calculated. This will be the same, we have in same way we have calculated the simplex method. So the old value of the column row divided by the key element. So the key element is 1, so it won't be affecting the values. So 1 1 minus 1 0 minus 1 0 0. Now how to calculate rest of the rows? So the formula for calculating is values of previous values of the row in the previous table subtracted by new values of the row into the key column value, means 10 minus 1 into 1, that would be 9. Same for rest of these, 0 2 1 1 0 minus 1, and here it would be 28 0 5 1 2 1 minus 2. Now again we will be calculating zj minus m into 0 for this. So it is coming out to be 4 minus 4 minus m 0 and m. Now cj minus zj, cj minus zj 0, cj minus zj is coming out to be minus 9, this minus this, minus m plus this minus this, minus 4 minus m 0 and 0. Sorry, over here we have to do cj minus zj, so it will be 1 plus 2m, and this is minus 3 plus m. So the biggest value over here is this, so this is our key column. Now how to calculate minimum ratio? Minimum ratio is xb upon key column. So this is 9 by 2 minus 1 28 by 5. The minimum value over here is this, so this is our key row. Now where the key column and key row are intersecting, this is our key element. Now we are going to construct a table 3 with the help of table 2. So table 3, the values will be the same over here, and our leaving variable over here is a1 and entering variable over here is x2. So our basic variables would be x2, x1 and s2, and the values over here will be 4, 5, -3, 0 and 0. Now the value of CB, x2 is 5, x1 4, s2 0. Now how to calculate the value of table 3? The value of table 3 will be calculated in the same way we have calculated the value of table 2. So the value of table 3 are 9 by 2, as 2 was our key element, 0, 1, 1 by 2, 1 by 2 and 0. Now this will be 11 by 2 and this 2 will also be 11 by 2, 1, 0, 1 by 2, -1 by 2 and 0, and this will be 0, 0, -3 by 2, -1 by 2 and 1. Now we will be calculating ZJ. ZJ CB multiplied by the rows plus adding these values. So it will be like 4, 5, 9 by 2, 1 by 2 and 0, and CJ minus ZJ would be 0, 0, -15 by 2 and -15 by 2 and this will be -1 by 2 and 0. Now as we can see, all the values are either 0 or are in negative. So here we are going to close making the further tables, because we are getting our maximizing equals to 89 by 2. Now 89 by 2, where it comes from? By adding these 4 plus 5, let me write 4 plus 5 plus 9 by 2 plus 1 by 2 plus 0. We are getting 89 by 2, and our x1 is 11 by 2 and x2 is 9 by 2 and our x3 is 0, as we don't have any variable of x3, and our s2 is equal to 11 by 2. And now we don't need this minimum ratio, so we will be putting a hash over here. So here we have completed the Big M method. Hope that you all understood the Big M method, and thank you for watching the video.